myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. Now, in this video, let us discuss about problem solving in C language. So, we will consider two problems in this video. One is called how to convert a Roman number into its decimal equivalent and how to find out the ones complement and twos complement of a binary number. Now, let us start with Roman to decimal conversion. Now, the task is to read a Roman number and to convert the Roman number into its decimal equivalent. Suppose, for example, if the input is IX, then its equivalent output is 9. So, IX is a Roman symbol which represents the decimal value 9 over here. Similarly, if the input is XL, then the output, the decimal equivalent is 40. Similarly, if the input is MCMIV, then the output is 1904. So, where M represents for 1000, CM is for 900 and IV is for 4. Now, in this program, before doing this program, we should know what are the symbols that a Roman number system contains and what are their equivalent decimal values. So, these are the symbols. I is for 1, IV is 4, V is 5, then IX is 9, X is 10, XL is your 40, L is 50, and XC is 90, C is 100, CD is 400, D is 500, CM is 900, and M is 1000. So, these are the different symbols and their equivalent values you must know. Okay. Next, another problem that we will discuss, that is called how to find out the twos complement of a binary number. Now, whenever a binary number is represented, it is represented as a string. So, using that, we can, that means in your array, we have to store a binary number in the form of a string. Then before computing the twos complement, first we have to compute the ones complement of the number and then we have to add 1 to that ones complement to get the twos complement of the number. So, how to find out ones complement of a binary number? Ones complement of a binary number is the inverse of each of the digits. That means if the digit is 0, then its inverse is 1. If the digit is 1, then its inverse is 0. So, if you will change the numbers, that is zeros to ones and ones to zeros, then it is called ones complement. So, for example, you can see here, ones complement of 0, 1, 1, 1 is nothing but 0 is converted into 1, ones are converted into zeros. So, 1, 0, 0. This is called ones complement. Similarly, 1, 1, 0 is changed to 0, 0, 1, 1. So, after finding out the ones complement of the number, if you will add 1 to that ones complement, then the resultant sum is nothing but the twos complement of the number. Now, let us switch on to our C++ compiler and try to execute these programs. Now, our first program is Roman to decimal conversion. So, start writing the header file #include stdio.h. First, write down the structure of the program, int main, and then return 0. After writing the structure of the program, first what you have to do, we have to read a Roman number. So, for that, we need one array, let us say character array of size 10. So, in this character array, we are going to store the Roman number. Then followed by, we have to declare another integer array where we have to store their equivalent values and sum it up. So, let us take total of 10 is an integer array where we are going to store the equivalent positional value of each Roman number into this array. And I is a looping variable. We need to find out its sum of each Roman number. You have to find it out the sum, and we will also compute the length of the Roman number. So, these are the variables we have declared. Now, first of all, you have to read a Roman number. So, let us write printf, enter a Roman number. use getString function to read the string. So we'll give getString of ARR. So our Roman number is read. So if you want, let me give my Roman number in lowercase. If I want, then I can convert this using the function strupr. Then this Roman number will be now converted into uppercase. So as I am using strupr, so let me write hash include string.h. As this strupr is a function available in string.h. Now my Roman number is now converted into uppercase. So after that, let me find out the length of the string using the built-in function strlen of ARR. So string length is computed. Now write down the for loop to iterate over the Roman number and find out the corresponding equivalent positional value for each Roman number. So for I is equal to 0 till I less than length of the Roman number, I less than length, and I plus plus. Now in this loop, what we will do, we will go for a switch case statement, switch on ARR of I. So first time I is equal to 0. So the character which is there at ith position, initial I is equal to 0. So at 0th position in the array, the character which is there, what is the equivalent value in decimal? That we have to store it into the integer array. So let us write down all the cases. So if the character is M, for example, if it is M, then M stands for 1000. So our integer array total of I should contain 1000. And you have to break it. Then if the case is D, D stands for 500. So total of I will contain 500. Break. Similarly, you write down for all the characters which can appear in a Roman number. So if it is C, then total of I will contain 100. Break. Similarly, if it is X, then total of I will contain 10. Break. Now similarly we have to write L also. L is for 50. So case if it is L, then write total of I is 50. So in this manner, for all the characters we are going to write. So if it is V, then it is 5. Total of I will contain 5. Similarly, if it is I, then total of I will contain 1. Break. So whatever the Roman numbers appears in your input, we have written for all the Roman numbers what is their equivalent value. So after this, what we are going to do, suppose the Roman number is given as CD. So the equivalent value for C and D we have to sum it up. So what we will write? We will write sum is equal to sum plus total of I. Every time sum is equal to sum plus total of I. So if your number is xi, then x positional value is 10, i's positional value is 1. So 10 plus 1, 11 will be there. But if a number is CD, then C's positional value is 100, D's positional value is 500. So sum you will get as 600. But the actual output for CD is 400. So after coming out of the loop, whatever the value is there available in the sum, we have to check it out and we have to write down the logic that whether the output is correct or not. So what we will do now, for example, if the number is CD, then we got the output, the sum as 600, but the actual sum should be 400. So let us write down the logic and change it to 400. Now let me write down the loop for I is equal to 0. Then I less than the length minus 1, I plus plus. So we will compare the values which is stored, positional values which is stored in the array. So if total of I is less than total of I plus 1, total of I, if it is less than total of I plus 1, then what you will do, we have to decrement the sum. So how much value you have to decrement? So sum is equal to sum minus 2 into total of I. This is the logic. So here, suppose the input is CD. So C's positional value is 100, D's positional value is 500. So this first time I is equal to 0. So in this loop, total of I is 100. 100 is less than your 500, yes. If it is 100 is less than 500, the first positional value is less than the second positional value, then remove from the sum 2 times the positional value of I. So sum is equal to, sum is 600 minus 2 into total of I. 2 into total of I is 2 into 100, which is 200. So 600 minus 200 is 400. So that is the correct output that you will get. Okay. So once the loop is over, then let us print the equivalent value. The equivalent decimal number is percentile D, comma, sum. Okay. So we have written the program. Let us first save it. So the program is Roman to decimal. .c. So saving the program is over. Now next we will go for running the program. Let us compile and run. Okay, so there is no compilation error over here. So it is asking me to enter a Roman number. Suppose my Roman number is xi. So internally it converts into uppercase, then it checks and the equivalent decimal number is 11. So my output is correct. So let me copy paste this output and we will run 2-3 test cases for this program. Let us go for another test case. Let us take input is CD. So the output is correctly, we are getting it as 400. So it is working perfectly fine. So like that, for 2-3 test cases you run and check your program. Suppose it is MIV. So the equivalent value is 1004, which is correct. So in this program, we have learned how to convert a Roman to decimal number. Now let us move on to another program where we will execute how to find out the 2's complement and 1's complement and 2's complement of a binary number. So let us go for a new file. Program is to find out 2's complement of a binary number. Hash include stdio.h int main and return 0. Okay. So first of all, we have to read a binary number. So how to read a binary number? So let us take one array A of size 10, comma, and looping variable I, n is the number of digits in the binary number. So first of all, we have to know how many digits are there in the binary number. That means, is it a 4-digit number, 5-digit number or 10-digit number? First of all, we have to know it. Okay. So how many digits the binary number is having? Just a message you have to put and we have to read the value of n. Percentile D, comma, ampersand n. So n is nothing but the number of digits in the binary number. Then we have to read the binary number. Binary number will be read one by one positional values, which is nothing but we need a loop and we have to read the binary number. So let me put a message, enter the binary number. So after that, let us read the binary number using a loop for I is equal to 0 till I less than n I plus plus. Okay. Now write down this scanf statement, percentile d, comma, ampersand a of I. So the binary number is read and it is stored into the array. Now we will call a function 2's complement and we'll pass the number of digits in the binary number and the array which contains the binary number. So let us write down a function for 2's complement. So what type of function it is? It returns nothing. So void. Name of the function is 2's complement. Name of the function is 2's complement and it takes two arguments. One is called the integer array and the value of n. So int n, comma, int a of size 10. Then how to find out the 1's complement? First you have to write down the logic for 1's complement, then we'll go for 2's complement. Okay. Now for iterating over the array, let us take a looping variable I and let us take initially the carry is equal to 1, because in most of the cases whenever you are finding 2's complement, 1's complement plus 1 when you will do, it may generate a carry. So how to handle that carry also we have to know. So initially suppose carry is equal to 1. Okay, first we will write down the logic for finding the 1's complement. 1's complement we will find out. Then we will go for 2's complement. So let us write down a loop for I is equal to 0 till I less than n I plus plus. So in 1's complement we will inverse. If the number is 0 we will inverse to 1. If the number is 1 we will inverse to 0. So that process we have to carry out. So let me check. If a of I is equal to 0, if it is already containing a 0, then make it 1. So a of I is equal to 1. Else a of I we have to, if it is 1, then we have to make it 0. So this is a very simple process to convert zeros to ones and ones to zeros. So when this loop is over, then each bit is converted from 0 to 1 and 1 to 0. That means our 1's complement is ready in the array itself. Okay. So let us print it. Printf 1's complement of the number. So how to print it? Again write down the for loop. For I is equal to 0, I less than n, then I plus plus. So print the individual digits. So printf percentile. If you want to give space, you can give 2d and a of I. So 1's complement is printed. Let us save this program and execute one test case whether 1's complement is coming perfectly or not. So Ctrl S. Program name is 2's complement.c. Let us run this first to check 1's complement is coming or not. So what is the error that you are getting over here? Expected semicolon. So yes, we have missed this semicolon over here. Okay. Now run it. Now how many digits are there in the binary number? Suppose 4 digits are there. Okay. Now enter the binary number. It is saying. So 1, 0, 0, 0. Suppose you have entered a binary number. So your 1's complement is 0, 1, 1 and 1. So it is coming perfectly. So 1's complement is working. So let us work on 2's complement. Okay. So how to find out the 2's complement? So for finding out the 2's complement, we have to add 1 to the last digit. So let us go to the end first and then we have to add 1 to that digit. If it is generates a carry, then you have to add to its previous digit. This process you have to continue if there is a carry. If there is no carry, then you have to simply add 1 to the last digit and you have to print our number. So let us go to the end. So for I is equal to n minus 1. N is the number of digits. So n is 4 suppose. So n minus 1 is 3. So I is equal to 3 means it is the last digit till I greater than equals to 0 and I plus plus. Now to the last bit, a of ith bit, I is equal to 3 over here. For example, so to the ith bit, add 1. So add 1 is nothing but the 1 is we have stored already in the carry variable. So we have added 1. Now let us check after adding the carry. Okay. So what is the value that you are getting? So if it is already 1, so 1 plus 1 will be 2. So if it is 0, then 0 plus 1 will be 1. So in this case, we will check that if a of I is equals to 1, that means it is not 2. Then what was the value? The value was only 0 there. So 0 plus 1 has become 1 now. That means you have to, there is no additional carry generated. So you have to make the carry 0 and you have to break it because addition part is over. But it may generate a carry if it is already containing 1. So in that case, you have to write down the logic for how to change that number because 2 is not a valid number in binary number system. If it is already 1, 1 plus 1 has become 2. So 2 is not a valid binary number system. So we have to make it 1 and you have to generate a carry. So what we will do? Now we will do a of I is equal to a of I minus 2. We have to do it and carry is equal to 1. Right. So this way we have handled. So the carry will be again added to its previous number. If it is again generating a carry, it will add it to the previous number and so on. This process will go on till I reaches to the 0th index. So finally, if the carry is left over, then what will happen? That carry we have to print it because that is there in the output. So after coming out of the loop, what we will do? Let us print the final output. So printf, let me give a slash n over here. Then print the 2's complement of the number. So 2's complement of the binary number is, how to find 2's complement? We have written the logic. Now let us check the carry first. If carry is equal to 1, then first you have to print the carry and then print the number which is there in the array. So what we will do here? We will write first printf percentile, your percentile 2d, some 2 space we are giving and then first print the carry. After printing the carry variable, then print the content which is there in the array. So for I is equal to 0, I less than n and I plus plus. The number which is there in the array, we have to display it. So printf percentile 2d, then followed by a of I. So we have printed the number which is there in the array. So let us save and compile and run this program. Check it. Okay. How many digits are there in the binary number? Suppose there are 4 digits are there. So enter the binary number 1, 0, 1, 0 for example. So 1's complement of the number is 0, 1, 0, 1. Okay, fine. It's good. Then plus 1. So plus 1 when you have done, then it has generated a carry. 1 plus 1 is 2. So we have handled it. So it is 0. Then it is your 0 plus 1 will be done. So 0, 1, 0, 0 is coming. Let us check the logic once. Okay. Now C is equal to 1. Okay. Let us go for another test case. Suppose the number is containing 5 bits. So it is 1, 0, 0, 0 and 0. 5 digits are there. So it is 0, 4 ones, correct? Then add 1 to that. Okay. So it is 0, 1, 1. 1, 0. Let us check it. If a of I is equal to 0, then a of I becomes 1 and otherwise a of I becomes 0. 1's complement is perfectly fine. So, till I is equal to n minus 1, till I greater than equal to 0, you have to do here not I plus plus, here I minus minus. This is the error that was there. It was a logical error, that's why you are getting wrong output. So, a of I is equal to a of I plus c. Okay. So, if it is, now let us check the output. Okay, let me take one 4-digit number. So 1, 1, 1, 1. So your 1's complement is 4 zeros and 0001. Let us take its opposite number. Let us take a 4-digit number and it is 0, 0, 0 and 0. All zeros. So all ones you got 1's complement plus 1 is the correct answer. Okay. So this is the correct output for this program. Now you can try this for different test cases. Okay. Let us try for another test case. Let us run it. Suppose let us take a 6-digit number, then 1, 0, 1, 1, 0, 0. And 1's complement of the number is 0, 1, 0, 0, 1, 1, correct? And 2's complement is 1, 1 plus 1 becomes 1, 0, 0. Yes, it is perfectly fine now. Okay, so we have done these two programs. Let us go for another program. So here we have learned how to convert a Roman number into its decimal equivalent, and also how to convert how to find out the 2's complement of a binary number. Now let us go for another problem. The program is, write a C program to read two numbers x and n and then compute the sum of geometric progression. Okay, so which is nothing but 1 plus x square and so on up to x to the power of n. Now here you have to perform error checking. In this. So for example, if the formula doesn't make sense for negative exponents, if it is not making sense for negative exponents, if n is less than 0. If n is less than 0. Okay. Now, if n is less than 0, then print error message and read the next pair of numbers without computing the sum. So if n is negative, then you have to read again the value of x and n without computing the sum. So find if any values of x are also illegal. So you test it. If any values of x are also illegal, that also you have to check it. So this is a simple program to compute the geometric progression for the series. Okay. Now for this, what we need? We need to read the value of x and n, and we have to do the error checking. So let us start writing the program. Hash include stdio.h int main and return 0. First of all, what you have to do? Let us take the variables x and n and a looping variable I, and we have to compute the sum. So initially sum is equal to 0. Okay. So we have to first read the value of x and n. So write down printf enter x and n value or values. Okay. Scanf. Two integers we are reading. So percentile d twice. Your then write ampersand x comma ampersand n. So two values we are reading. Then you have to do the error checking. How to do the error checking? Check whether x is negative or not. If x is less than 0, okay, or if n is less than 0. If any of the values are negative, then printf, what we will do? Let us write error or erroneous data, erroneous, or let us write simple error in input values and read it again. That's the message we have to go for. Okay. Now, how to read the values again? For that, we have the printf scanf statements. So let us do it. Let us use a go to statement. Let us copy this statement and put it inside the braces. Okay. Now we have to go and read the input again. So write down go to read. Read is a label here. So where we have to keep the label? So we have to write down the read label here. So our control will do a unconditional jump and go to the printf statement to read the values of x and n again. Now, if there is no error in the data, that means both the values of x and n are positive, then what to do? Then you have to go for I is equal to 0. Then we have I less than is equal to n and I plus plus. We have to compute the sum. How to compute the sum? So sum is equal to initial sum plus use the power function, power of x to the power of I, x comma I. Okay. And we have used the power function. So write down the header file hash include math.h. After computing the sum, let us display it. So printf sum of the series, sum of the geometric progression GP series is nothing but percentile d, the value of sum. So this is the simple program. Let us save it and run it. Geometric progression .c. Compile and run. Okay. Enter the value of x and n. Suppose I am giving x is equal to -3, y is equal to 4. Yes. Error in input values. Read it again. So the control is jumping to the read statement. So read label. So where it is showing the message, enter the value of x and n. Now I will take 5 and -1 or -2, n value 0. Still it is showing error in input value, read it again. Now if I will take x is equal to 2 and n is equal to 3, then the sum of the GP series is 15. Okay. So you can try all these 2-3 test cases and you have to check whether your program is working properly or not. So let me copy paste the output. paste it over here. Okay. So this is the program for finding the geometric progression series. Now let us go for another program for computing the GCD of two numbers. Now, how to find out GCD of two numbers? So, let us compute GCD of two numbers. To compute the GCD of two numbers, we will use the method of recursion over here. So, let us start writing hash include stdio.h int main and return 0. First of all, we have to read two input numbers. So let us take int x comma y and we have to store these values. So we'll take another set of numbers or variables called m and n. So first read the value of your m and n. So let us write enter two integers m and n. Then read the values using scanf statement %d twice comma ampersand m comma ampersand n. So two numbers we have read it. Then for computing the GCD, what you will write? X is equal to, we'll call a function GCD and we'll pass the value of m and n. Okay. Now we will also compute the LCM, which is nothing but the y value. So if you know the GCD, then LCM is also easy, which is nothing but multiply the original two numbers m into n divided by GCD will give you the LCM. So here y is LCM of two numbers. Okay. Here the value of x is GCD of two numbers. Okay. So after getting the LCM and GCD, let us print it. Printf LCM, or let us first write GCD is equal to %d comma the value of x is GCD and LCM is nothing but is %d comma y value. Okay. Now we'll write down the logic how to compute the GCD first. So for that, let us take the help of the function. The function returns some value. So what type of value it returns? It returns integer. Name of the function is GCD. It takes two numbers. So int m comma int n. So what type of function we have used over here? We have used a function with arguments and with return type. Right. Now, if one of the number is 0, suppose if n is equal to 0, then the other number is the GCD. So, return your m. Otherwise, how to compute the GCD using recursion? Then you have to write down the logic. GCD is nothing but interchange n comma m modulus n. This is the logic for finding the recursive logic for finding the GCD. Okay. Now save this program gcd.c, right, and let us test it how it works. Enter two integers. Suppose 4 and 8 are the two integers I am entering. Then GCD is 4 and LCM is 8. It is working perfectly. Now let us go for one more input. Paste this output first. Control V. Right. Now let us test it again for some other number. Let us take 5 and 15. So GCD is 5, LCM is 15. So it is working properly. In this video, we have learned a number of problems using C language. So we have written the programs for Roman to decimal conversion, 2's complement of a binary number, and also how to do the geometric progression series, followed by how to find out the LCM and GCD of two numbers using recursive approach. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.